Okay, all right. So we're going to merge things together. We now know how to do the composition. And last week we talked about, the, what is it called? Domain. What's domain again? All the x values that are possible, right, for the function. So, so let's go ahead and warm ourselves up. What is the domain for f in this case? For the domain of f, so you look at f, can x be everything? And you're shaking your head and say, no, x cannot be everything because you don't want the number underneath the square root to be negative, right? So that means x could only be as small as -3, because that would give you 0. And it can go a lot bigger, because that's fine, because we would not risk getting a negative number if the number is bigger. But we definitely do not want any number that's smaller than -3, because that would give us an imaginary number. And then for g of x, we say, oh, g of x is x squared. Can x be everything or anything? We say, yeah, sure, no problem. Then we say, oh, it's from -infinity to infinity. So that would be the domain for g. So now we say, oh, yeah, what about the f of g of x? F of g of x. Then we say, oh, if that is the case, then we say f of g of x. Okay, you insert it right here. Okay, and then we say, all right, just think about this. In this case, with this new look right here, square root of x squared plus 3. Can x be any number? And you think about, can it be positive? You'd be like, yeah, positive is fine, because you will still end up with a positive number underneath the square root. Can it be negative? Like, can it be -10 in this case? And we'll be like, yeah, sure, because -10 squared would be 100. It's a positive number, so that would also be fine. So one thing you can see here is that the domain of the composed new function would tend to stay with the inside one. Okay, is it always like this? I would say could be, but I like to look at it every single case individually. Now, what about g of f of x? Then we say, well, g of x is the outside, so x squared, and then you put the f function inside. Now, this could cause a little bit of a discussion right here. Can x be any number? How many of you say, yeah, x can be any number? How many of you say, no, x cannot be any number? All right, cool, cool, cool. If you say x cannot be any number, that is correct. Now, but there are some people, they may argue this. They would say, but wait, Mr. Chan, take a look at this. You have the square root right here. You have a square out there. Don't they cancel each other out? And if that's the case, then x could be any number, isn't it? Well, that argument is somewhat valid. The problem is that when we look at domain, we always look at the original notation, the original function right there. So we assume no processing. It's very raw. We are not going to cancel the square root with the square. So this is what we have. And we will say, yeah, the domain, it's from -3 to infinity, including -3, because we still do not want the number underneath the square root to have a negative number. Yes?
Is that because of the order of operation? You have to do inside, you have to do it inside.
It's an order of operation. I didn't think about that as an order of operation.
Because you always have to do the inside before you do it.
Should be, but it's more about if you don't cancel anything, just based on what it is right now. Would a negative number underneath the square root work? Then we say, It won't. Okay. Later on, we'll see more, and that's the reason why I tend not to think about order of operation. It's more about you have to resist the temptation of processing resist the temptation of simplifying these functions. Okay. All right.